In this video, we're going to be talking about this periodic continued fraction a plus 1 divided by b plus 1 divided by a plus 1 divided by so on and so forth. Now, this pattern is obviously somewhat self-similar. So we have already seen that the self-similarity can be utilized to calculate values of these expressions, provided that they define a convergent sequence. So let's just look at our previous example, this 1 plus 1 divided by 1 plus 1 divided by for an hour. Now, this infinite continued fraction was the very same expression as this denominator. So this expression contained itself. Now, let's look at our current example. What's going on here? It obviously contains itself, but not in the very same level, because a and b are repeating themselves in periods. So this specific denominator will be the entire expression itself. And if we assume that this sequence converges and we are denoting the limit with lambda, then we can perform calculations with these expressions. Now, notice that this a plus 1 divided by b plus 1 divided by, it's the entire expression itself, it's lambda. Therefore, we are obtaining this equation. A plus 1 divided by b plus 1 divided by lambda equals lambda. So the only thing we did was we substituted this specific denominator with lambda. Because of the self-similarity, we reduced this kind of convoluted and hard to understand concept into this very simple model. Now, if we are manipulating this expression and we are simplifying it, it's blatantly obvious that it's going to lead us to a quadratic equation in lambda. Now, if we solve this quadratic equation, we obtain these two roots. Now, we're going to just dismiss the negative root for obvious reasons. Therefore, what we are currently dealing with is that this periodic continued fraction is, if converges, a times b plus square root of a square b square plus 4 times a times b divided by 2b. Now, just look at one specific example. Now, assume that we are having this periodic continued fraction. 1 plus 1 divided by 2 plus 1 divided by for an hour. Now, our a term is now 1 and the b term is 2. So we are only substituting into this expression, and thereby we are obtaining that provided this expression converges, then the value is going to be 1 plus square root of 3 divided by 2. Now, you can kind of very easily generalize this pattern into more convoluted, into more general forms of this periodic continued fraction. You can see that you're not having only two terms which are periodically repeating, you are having n terms which are periodically repeating themselves. So you are having this periodic continued fraction. And now if you assume that this expression converges and you're calling it lambda, because of the self-similarity, you can write this equation. And when you're simplifying this, it's going to lead to another quadratic equation. And now, because of this, we can conclude that no matter how convoluted and how complicated our continued infinite fraction gets, we are always capable of solving this with reducing it to a simple quadratic equation. Thank you so much for watching.